I was recording using another software. It's okay. Let me check if I click. Yeah, I'm sure I clicked record. I'm using a software on my desktop to record. And I'll share the video after. Right. So. You're also going to identify opportunities for application of data and critique existing visualization based on data visualization theory and principles. And we are going to use the ARA programming language to develop interactive visualizations. And we're going to be doing lectures, peer teaching as learning strategies, practical sessions, discussions, group assignments, and this time we're not going to have presentations since we are doing online learning, and we're also going to have a project method. And if you noticed, if you checked your assignment, I gave you a mini project as an assignment, and the medium of instruction will be English. However, the use of vernacular during the classroom participation may be used. Right, so that is what we are expected to do or to know or to have gained at the end of the lecture. So these are the topics that we are going to look at. Introduction, tools for simplifying complex data, exploratory data analysis, statistical graphics, large data sets, multivariate complex data, text data analysis, geospatial data, and then some principles behind visualization, like improving comprehension, communication, design making. We're going to talk about these theories, and I would expect you to apply these theories in your visualizations or in your projects in this module and in your careers. So we are also going to look at systems and applications, and with other theories like the visual art, perceptual psychology, and we're going to look at heterogeneous systems, technologies of visual analytics. Right, so these are the this is our course outline, and so we'll see what we are going to be able to cover with this limited time that we have. But I've structured it in such a way that we cover most of the stuff that can make you go home with something at the end of the day. Right, so we're going to the continuous assessment. The coursework is going to constitute 40%, with a mini project constituting 25%. The one I gave you, we're going to look at. I'm just going to go through it with you, and we're going to have practical assignments, which is going to constitute 15%. So I'll just pick these assignments from our lectures. I've written exercises after every lecture, and so I'll then later on pick one or two and make them part of your assignment. And then the term paper, we are not going to look at the term paper as an assignment. Then the final examination is going to constitute 60%. So it's a 3 to 4 hour paper marked out of 100, and the exam comprises of 6 questions, each carrying 25 marks, and you only choose 4. And like I said, it's going to be a practical examination, and it's also going to be an open book exam. Now let me clarify on open book. Open book I'm going to allow you to bring your notes, but they are going to be hard copies. So whatever notes you find, try to summarize them. Make them as short as you can, so that when you print your notes to bring to your exam, they should be compact, not bringing volumes of books in the exam room. Right, so it's going to be an open book and a practical exam, and so this is the grading system and the reading list and the assignment. So the dates of the due date of the assignments will be announced. So I'll be communicating with the class rep, and we're going to use Google Classroom for all our exercises, uploading of assignments, and I'll also be uploading notes, codes, and even the exam you're going to submit via Google Classroom. After writing the exam, you finish and you then submit on Google Classroom, so that we don't spend much time trying to collect your exam using a flash drive. So last time I had challenges with some who were not able to submit on Google Classroom. So well, this is not going to be part of the lesson teaching you how to upload on Google Classroom. I overlooked it last time, and later discovered that not all of us are able to do it. So during this period, just go and familiarize yourself with Google Classroom. See how you can upload, how you can gain access to the uploaded notes, how you can do one or more things regarding to submission and accessing learning material. So last time I had challenges with people failing to upload, as because the exam is going to be individual work, and assignments, since it's going to be group work, you find that only one person will upload and the rest may not bother themselves to see how you can upload yourself. So that is our course outline. Now let me now move on to the assignment. Let me upload the assignment. All right, so that's the assignment, and so I'll read the question. So we want people to grasp what is required before you start doing your assignments, and before you start choosing your group mates. So the question is, you're going to create an Shiny application. An Shiny application for a Zimbabwean organization of your choice. So it's going to be for a Zimbabwean organization of your choice. So the minimum requirements, okay, if your screen is not showing anything, you can try to refresh the page. You can try to refresh the page. Now, sometimes if internet connection is slow, you can try to refresh the page, or you may be missing some slides as we are moving on. Now, so the minimum requirements of this mini project are as follows. Your RFINE application must visualize geospatial data. So you will see during our lectures what geospatial data is. Just define it and give you some 1 or 2 notes for you to know what it is. But since you have been given an assignment, you can always go ahead and read and try to find out what it is before you tackle the assignment. So I want you to use 7 visualization techniques. From 7 visualization techniques, I've given you examples there, and I want you to use multiple data sets, not just one data set. At least 2 is okay, 2 or more data sets. So I want to download or look for 2 data sets. If you can't find the data sets for the organization of your choice, you can create your own data set. Okay, I'm not going to look for the authenticity of the data, but I'll just want to look at to see you applying the techniques and answering the question according to what you are required to do. So authenticity of the data, it does not matter, but don't over exaggerate. Okay, so your visualization must include 7 techniques, and the examples of the techniques are choropleth map, a heat map, a hexagonal binding, dot map, cluster map, bubble map, cartogram map. Right, so you're going to use at least 2 okay, did I mention? Okay, all right, so you're going to visualize data for an organization of your choice, geospatial data, using these techniques. So for a heat map, you can you show us, you demonstrate to us how a heat map is visualized, how data is visualized using heat map. Right now, and in your application, I expect you to include the following aspects: interactiveness and visual and narrative techniques. And I've given you examples. You may not use all of these on part B, that is select, explore. Now, as the user is using your system, your application, they must be able to select, and I've given you definitions, mark something as interesting. They must be able to explore, reconfigure, encode, abstract, filter, and connect things in your application. Now, when you finish your application, I want you to deploy it online for clients to use it. I want you to deploy it online for clients to use it. So the whole idea is for us to analyze geospatial data using your application, your RShiny application. And so you are going to upload it, but you are going to upload, and at the same time you're going to submit your files, everything that you have done to me to see that it's you have done it. Right. So additional requirements, you're going to write at least 1-page summary describing the insights that you have gained from these visualizations. So you're going to tell us discoveries, revelations, surprises, etc. What you have discovered from your visualizations. And you are going to include comments in your R scripts describing what your code is doing and what techniques you are demonstrating. So we're going to look at the RShiny application together in this course, how to come up with an RShiny application so that you know how what you're expected to do. But you can always go and research before that, before we get to that lecture. But since we are just going to have 4 days, I'm sure we're going to look at it soon, and then you can go and start your assignment. Now, general grading criteria, I'm going to grade you according to the techniques, skills, principles, and ideas that you have used in your project. And the data processing, like I said, if you can't find a data set for an organization, create your own data set. But I know if you are creating your own data set, people have a tendency of creating a simple and non-complex data set, and hence data processing will be minimal. And if I don't see some kind of data processing before visualizations, you won't get more marks. Then the sophistication of the visualizations, and you are expected to show some creativity. I'll award you for that, and the effort that you put in. If I see that there wasn't any effort put in this project, then obviously you won't get more marks. Now, submission guidelines. I want the names of the group members. So you choose, I don't know how many are you in your class, so that we can agree on a minimum number of members per group. So maybe we'll discuss that later. So you choose your own group members, and so you write their names. You submit your R code or R source code or R scripts. Then a PDF with a description about your insights, and then the data sources or the data sets used. If you have created your own data sets, you can share or you can submit the data sets together with your files. If you have downloaded a data set from anywhere you have downloaded it, you can share the link, or you can always download it for me and put it in your folder. Then put everything in a zipped folder and submit on Google Classroom. And as well as, since you are going to deploy it online, you are also going to share the link to where you have deployed your app, so that again, we visit the link and start analyzing data there online. So you can also send a README file. You can also send a README file containing necessary instructions and any other notes that you would like me to read. All right, so that is your assignment, your mini project. So when choosing your group members, make sure you do your groups are balanced. You see, when we do other Shiny application, you may need someone with some knowledge, a bit of some knowledge in web design and web development, and someone who appreciates programming. In fact, you were supposed to start by doing programming in this semester, but I don't know why you started with data visualization techniques. But we're going to, there are a few programming principles that you are expected to apply in other Shiny application, but not much, not deep programming, but just a little bit of knowledge of programming would help. So that is our assignment. But then date of submission, we are going to agree when we can submit. Right, so so let's begin. The first lecture. So today we're just going to look at mostly theory, and then I'll introduce the ARA programming language and software, or the ARA Studio IDE that we're going to be using for this course. And so that tomorrow when we start our practical lessons, so from tomorrow to up to day 4, we'll be doing practical sessions and practical topics. So I would expect you to, when we start tomorrow, you will have installed your ARA and everything, and we just want to look at some basic ARA programming principles, so that we will try to move a bit faster starting tomorrow. Right. Data visualization techniques. No, so normally I normally ask this question before starting. Signal strength. This is signal strength for Wi-Fi or internet connection. Right, so this is data, and with -7 dBm, -70, -30, -80, -90. If you are asked to choose the signal strength that you would want to use for internet browsing, which one would you choose? Maybe I can have a few answers from you. Okay, let me pick Aronzo.
I don't have an idea.
Okay, just make a pick.
Just a pick. Maybe -90.
-90.
Yeah.
All right. Well, how about Amanda Dewey? Okay, I'm having answers. Someone is saying 90, -30. Tawanda Mendy is saying -30. All right. So let's work with this. Let's work with these three answers. These two answers, 90 and -30. Right. So let's see the results. Now, so the signal strength is minus 30 is amazing, and Aaron chose unusable Wi-Fi signal. Now, so you can see that it was difficult to make a decision because you did not know which signal strength was good for you, unless if you are someone from telecoms. It was going to be easy for you to make a pick, right? Now let's see the difference when we visualize this data. Or I'll ask Aaron again, which signal strength would you pick? 1, 2, 3, or 4?
I'll choose 1.
1. We can all see that he made the choice quickly because the data is now in visual format. Right, so it was now easy so it's less than greater than minus 50 dBm, and if it's less than minus 90 dBm, it becomes weak up to unusable. Right, so it was, as you can see, it was easy to make a decision when the data was presented visually. But when we had the data in this format, it was difficult to make a decision. Right, so that is what data visualization is all about. Okay, so we can see that humans, we perceive things in a variety of ways, and vision is considered the most dominant sense when perceiving things. Okay, what we see is what we are able to act upon very quickly. Right. So nowadays you can see that data is generated everywhere. You make a phone call, data is being generated. You send a text message, data is being generated. You go to the bank, you buy something online, that is being generated. You swipe your ATM card, that is being generated. And more than 1 billion gigabytes of data is generated every day, and if not terabytes of data. And more objects, trillions of them, are connected, and they are generating data every day. So data visualization is a well-reached and interdisciplinary area that combines knowledge from various disciplines. Now, see, this data that is being generated every day, we need to act upon what it offers to us, be it in business, and mostly for decision making. So data visualization is a cognitive process that is used for analysis and presentation. So the whole idea is for us to understand data better. Like the example I gave you, when I gave you numbers, it was difficult to understand the data, but when I gave you a visual representation of the data, it was now easier to make a decision. So it must offer you an opportunity okay, just a minute. My recording software has stopped recording. Okay, since I'm recording on on big blue button. Let's just continue, and maybe we'll be able to get the video from there. Now, so I was saying, when we understand data better, it gives us the opportunity to act upon the understanding it offers. For it enables effective communication and presentations. That is what data visualization is. It gives us a better understanding of the data, and we can act upon what we've understood and be able to make a decision. So that is what Chen said, and Coursera 2007 also defined data visualization as a process that is based on qualitative or quantitative data. So we have data. So remember, we said in the beginning that data is just everywhere and is generated everywhere. So visualization deals with the data, and data can be qualitative or quantitative. And B, it results in an image that is representative of the raw data. So we need to represent that raw data in form of an image that is readable by viewers and supports exploration, examination, and communication. Right, so that is what data visualization is. So we have many authors and many writers who talks about data visualization, and here we can see that it's mainly trying to convert raw data into pictures, or the presentation of data in pictorial format or graphical format. And why do we want to do that? So that we can make decisions, so that we can grasp difficult concepts, or we can identify new patterns. But the umbrella term, the word is to be able to make decisions. So it all talks about graphical representation of raw data that is difficult to perceive without before it being converted to an image. And here we can talk of converting it to elements like charts, graphs, maps, and by so doing we can understand trends, outliers, and patterns. So many professional industries benefit from making data more understandable. Like I said, this is a course that is useful for many industries: science, finance, marketing, government, history, consumer goods, on social media, etc. Sports, education, they need data visualization. Right. So the history, it started in the 17th century, or the invention of the pie chart was in the 18th century. So this concept originated from statistics and science, and it was advanced by NCSA, National Center for Supercomputing Applications, and we have newest developments by Xerox PARC in virtual reality. And if we look back to the World War, we can see that Charles Minard mapped Napoleon's invasion of Russia, and the map depicted the size of the army as well as the path of Napoleon's retreat from Moscow. So they presented that information visually for people to understand, and people were able to understand the event and what Charles Minard wanted to do. Now, so what is the goal of visualization? It is, number one, to explore. If we know nothing about the data, we visualize to explore it and to find what we don't know is something that is in the data, inside the data that we do not know. We explore it using visualization. Like, suppose you get data from, or someone gives you their data for analysis. You can explore it by visualizing it. It's different from someone who have generated or created the data, him or herself. But if you don't know what the data entails, then you can explore it visually. Visualization helps you to explore it. Then you can also visualize, you can also use visualization to analyze. Analysis. Suppose you now know what the data entails, then you have hypothesis about the data. You can use visualization to verify or to falsify. Verification or falsification. What I have, is it true or not? I've heard that many poor people died in the Titanic. Then I have the data set, I plot graphs to verify that or to prove that is wrong or not. And you can use it to find patterns. Then after that, you can present. Now this is done for maybe decision making. You know everything about the data. You now know everything about the data. You have proved that it's correct. Then you present it to communicate the results. The CEO, or if you are a CEO of your organization, you would want data to be presented or to be visualized to you so that you can make a decision. Let's see trends of our sales during the past few years. You see a line plot showing that our sales have been increasing, right? So data is now presented to you visually. So that is the goal of data visualization. So we have types of data visualization. We have scientific visualization. This is structural data mainly, and we see it in medicine, chemistry, seismic, etc. And this is mostly concerned with data defined in physical space, and it's normally 2 to 4 dimensions. We're not going to be looking at this kind of data because they need experts like chemists. They know their molecules, the shapes of the molecules. You see circles joined together, and they are the ones who understand what is going on. But we are not going to look at data, at visualization in that regard. So we also have information visualization. Normally here we don't have any structure or any inherent structure like information from social media. People are just talking, and information like news, the stock market, top grossing movies, Facebook, connections, etc. And this is normally high dimensional data, which is something above higher than 4 dimension, and abstract. It is abstract data and normally represented by trees, graphs, hierarchies, and the data is discrete in nature. So we find this kind of data in financial, marketing, HR, statistics, social media, political forums, etc. Right. So, well, we may want to analyze this kind of data. We'll see later on, and the general forms. Some they call it forms, some types, some they call it methods of data visualization. So, depending with the author. So, I've just written forms, types, methods of data visualization. So we have charts, tables, graphs, maps, infographics, dashboards, area chart, bar charts, and many more. So you go and since I've given you these notes, you can go and read these. So we are going to look at some of these forms of visualization in our course. Why is it important to visualize data? It helps us to read, analyze data and information with higher speed and accuracy. Now, I don't know if you all noticed it, but I did. When I asked Aaron to tell us the signal that you would want to use for internet browsing, at first he said, I don't know. But when I asked the second time with visualization, he quickly said number one. So it helps us analyze data and information with higher speed and accuracy. If you are given a list of figures, it's difficult to look for trends or patterns. But if those numbers are presented visually, it becomes faster for you to make a decision. So data visualization is important to create meaningful information and decision making power in the brain. Data is useless if it's not creating any meaning. So visualization creates meaning to the data. So by giving us productive data and present it to users. And we can also see different perspectives of the data when we visualize. So there are many benefits for data visualization that we can talk about. So it also makes it possible to interpret vast amounts of data. If data is with too many records in our data set, then it becomes difficult for us to analyze if we don't visualize the data. But if we look at data visualization, then it will be easy for us to analyze it quickly. So we can explore trends and allow the analysis of visual patterns in the data, etc. So that's the benefits of data visualization. So there are many benefits that I've written there. I'm sure we've grasped what we are talking about. And here let's talk about the visualization process. So what starts is data acquisition. You generate data or you collect data. Right, like I said in your assignment, if you can't find an existing data set for that particular organization that have geospatial data, you can collect or create your own or generate your own data. Okay, so after acquiring the data, you enhance it, you process it. Normally, you find people, maybe you are put in a position of just being asked to analyze the data that you have not collected. And normally, people, when they are collecting data, they make mistakes, they skip, you find data with missing variables, missing entries. Some they've not recorded the data in full or correctly. So what you need first is to process the data. After you acquire it, you process it. Then you do visualization mapping. You map it to visual primitives, e.g. colors, geometry, etc. Then you render, that is giving output, and you create an image in form of a chart, a bar graph, or a map, or a word cloud, whatever. Then you render your visualization. Now, for analytics now, the process is the same. You acquire the data. Since you are doing that big data analytics, you are not going to end at visualization only, although this course is going to just talk about visualization, but you are going to go a step further and do some analytics. Now, so you need to acquire or generate data. You pre-process the data. Now, if you notice, the first step, we just processed the data, but this time we are pre-processing it. Pre-processing it because perhaps you want to apply or to use some algorithms or some techniques to be able, that enables you to analyze the data. So for example, you can do some feature detection from your data. You can do some structure extraction. You can do some statistical analysis, etc., etc., using various methods like machine learning, algorithms, artificial intelligence, and many other methods. After doing that, you then map the data to visual primitives. Oh, Aaron, you wanted to say something? Or you are...
I know my network was bad, so I was trying to reconnect.
Oh, okay. All right, it's fine. So as a data analyst, right, this do I have a pen here? Okay, this part is where you come in mostly, although you can do data acquisition and this part and this part and this last part, but this part, the analytics part, is what you are supposed to be doing. Okay, right. So that's when you can use some data science methodologies like machine learning, even statistical methods. They are also used as part of data analytics. And you can use, we also have artificial intelligence. We have many methods that we can use for analytics. Right. So after that, you then render your output as images, and people can now make a decision. So what makes a good data visualization? Everything depends on the concept of layering, establishing hierarchies and making them clear. So you need to make your visualizations in such a way that you challenge the viewer to think about the substance rather than the methodology, rather than the graphic design. When you do your visualization, you don't want people to comment your pie chart. Oh, that's a nice pie chart, rather than commenting on the data it's presenting to them. Okay, that's the idea. You need to challenge the viewer to think about the substance. What is it that you want people to see? You want people to see the data, to visualize the data, rather than wanting them to visualize your pie chart or your bar graph. Okay, so you should encourage the eye to, you should also encourage the eye to compare, review the data at several levels of details, from a broad overview to minute statistics. So that is what you should look at when making good design. So there are principles that we are going to talk about in a few minutes. So practical uses, like I've given you a simple example of Wi-Fi or network signal, Wi-Fi signal. We see that every day on our phones. You want to connect to Wi-Fi, you look for all close nearest Wi-Fi broadcasters, and you see, oh, this one is better, because you have seen you have seen an image to tell you that this is 4 bars. We can see it. We see data visualization every day. You pick a remote, a TV remote, to increase volume. How do you know that your volume is low? Because there's a bar that shows you that, oh, volume is over to my extreme left. If you increase, you see the volume increasing to the far right, and you are convinced that the volume is at maximum, because you have visualized that instead of using that visualization, they would use maybe figures and numbers. You would know that my volume is at maximum or not, because you may not maybe be in a position to interpret the numbers and the figures. So data visualization tools need to be integrated into most all the business applications, such as websites. Now, this is where your assignment becomes useful, right? So that other shiny application becomes a tool which you can integrate to your website. Suppose you are creating an other shiny application for your organization, and you have hosted it. You can go to your website and give a link that will take you to other shiny application for people to analyze data. Suppose you work in a supermarket, you want to analyze your sales, your daily sales. You just create your tool, your shiny application. For instance, you give the manager a link or the CEO a link. They just click that link, they go to that other shiny application, and they start to see visualizations of sales, line charts showing that sales are increasing or decreasing, pie charts showing which group of commodities are selling better than the others, etc. So that will help them make decisions. Okay, so that is the tool that you need to integrate into almost all business applications, such as websites, marketing tools, Facebook analytics, and we've seen that in Google Analytics. If you go to Google Analytics, you see visualizations of usage, trends, etc. That is all data visualization. Right. So these are the references, and that's the end of chapter 1. So we're going to look at, I've 11 chapters to look at today. Some of them will be rushing through because of our time, but it's basically theory behind data visualization that we are going to be looking at. Okay, just a moment, let me answer this phone. Hello? Dream lecture, what is? Alright. More try for lunch, but don't need up lunch. Alright. Alright, so here with basic visualization techniques and methods. Right, the data is presented as one-dimensional or two-dimensional or multi-dimensional. One-dimensional is we're talking of one variable. Two-dimensional where we have x and y plots, and multi-dimensional we're talking of relational databases where we have more than two variables. Then we have hierarchies and graphs. That is data with relationships to data, and we also have metadata, that's structured data with associations, links, identifiers like web pages, etc., etc. So when you are doing visualization, you need to know the type of data you are dealing with, so that you'll be able to know how you can work with the data. So categorization of visualization methods. Like I said earlier on, with various authors, they categorize it, these methods differently. But generally, we are just going to look at the three categories. That is information visualization, software visualization, and scientific visualization. But we are more concerned with information visualization for this module, so that we can be able to accommodate almost every industry. Scientific visualization helps to understand physical phenomena in data, mathematical models, etc. You know, we are not going to look into this one in details. Normally, these kinds of visualization is needed by specific people or experts in that particular field. Then software visualization, we're not also going to look at this in detail, but it's just for you to go and read and find out. Then information visualization is the depiction of information using spatial or graphical representation to facilitate comparison, pattern recognition, change detection, and other cognitive skills by making use of visual system. So we can further categorize information visualization as data visualization, then information. Some they interchange these two words, data and information visualization, right? So here we are talking of quantitative data with or without axes in schematic or diagrammatic forms. For example, tables, lines, chart, pie chart, histograms, scatter plots, etc. And information visualization is an interactive interface of data to increase cognition or perception ability. Like I said, we are talking of how people perceive things, and we've seen that vision or seeing is the most dominant. So I want to take advantage of that and be able to make visualizations that increase cognition and perception to the viewers. So we have examples with data map, tree maps, clustering, etc. So information visualization is very broad. So we're just going to look at data visualization techniques from if we look back to our course outline, we're going to look at those aspects only, and you can then maybe go and expand to this if you want in for your, depending on your career. Now we also have concept visualizations. We're not going to look at that. The mind maps, layer charts, concentric circles, decision trees, but just read. Like I said, since your exam is a practical exam, I won't be asking you this in the exam, but it's just for you to know where we are going. So information visualization categories is strategic visualization, metaphor visualization, compound visualization. You can go and read this, but this course focuses on data visualization. Again, like I said, data and information, some they interchange the two words, but what we want to be talking about is the data that needs to be analyzed and represented in a meaningful form, which is easy to understand and interpret. So we're going to look at data in that sense. So mainly if I say most importantly, we want to talk of business data that gives us gives us maybe a competitive advantage in business and our day-to-day living, business, health care, and yeah, mainly that kind of data is what we are going to be looking at. Now we are going to set aside data from experts, like chemical formulas, visualizing chemical formulas, mathematical models, etc., etc. We're not going to look at that. Right. So that is what we're going to be looking at. So with techniques for visualization, visualizing data with geometric techniques, like I said, you can go and read this. It's just for your theoretical foundation for this course. Pixel-oriented, etc., area-based visualizations, point-based visualization, line-based visualization, and a hybrid. Right. So that is basically, here we just wanted to talk about information or data visualization, what it is and what we are expected to be doing in this course. Now, before I think we'll take a break at 9, just a 5-minute break. So I'm sure we'll be done with chapter 3. And we'll be taking breaks here and there until we finish. Right. So design principles. Now this is very important. Now I'm not going to ask you design principles in the exam, or in real life. No one will ask you design principles, but you should be able to apply these principles. Okay, before you make your designs, this should be at the back parts of your mind, or before you make your visualizations. Right. So design principles and theory. So the main difference between effective and ineffective data visualization is the ability to communicate key messages in a clear and straightforward way, such that it does not overload a viewer's working memory capacity. Visualization. Okay, so it should be simple and clear and straightforward. Okay, you don't need to overload people's working memory capacity. People just need to see, oh, this is this, oh, this is that. So hence there is need for design principles to ensure simplicity of design with complexity of data. No matter how complex the data is, you should come up with simple designs that present what you want to present. So we're going to look at design principles, or we are going to borrow principles from literature, and so we're going to borrow Edward Tufte's design principles, and we're also going to borrow Gestalt principles of perception. Right. So these design principles are very, very important when making your designs. So Tufte's 6 design principles are as follows. You should show comparisons, show causality, use multivariate data, completely integrate modes, establish credibility, and focus on content. Right. So these principles can be grounded into 2 main concepts that support meaningful data of visualization, which are simplification and emphasis. Whenever you are making your visualizations, you should look at simplifying your visualization, no matter how complex the data is, and should emphasize, make sure you make emphasis to what you want to visualize. Like I said earlier on, don't make people appreciate your chart. Make people appreciate the data that you are presenting. Okay, so simplification, you need to show comparisons. It's easy for people to see things when you compare things. Legend simplification, you need to simplify your data, you need to simplify your colors. Don't be too fancy with colors, especially women and ladies. This is not a time to show how good you are in choice of colors, but you need to just be simple in color choices. Then emphasis, you need to emphasize. You can use, we will only allow you to use color when you are emphasizing something, so that the user or the viewer may see what you are trying to say or to portray. You can also label, to emphasize by labeling. You can emphasize by weight, giving weight, like say if something is bigger, you give it a bigger weight of a line. The line becomes bolder than the others. You can also establish credibility. Now, so for simplification, graphic designers support comprehension, and by simplifying visualization to the extent possible. You should discourage, the strategies include discouraging 3-dimensional displays, removing extraneous grid lines and decimals, avoiding color gradation. Okay, this is not a design course like graphics design, like you are doing Photoshop or background design. No, so you should avoid all that. So Tufte used 2 terms: visual noise and non-data ink. Don't create visual noise. That's adding something that does not aid to the understanding of the data that you want to display. Don't put fancy colors that are not useful. Instead, they will become visual noise. And the non-data ink principle. So, for example, I have a few examples. The first graph here with there's too much data in, and that is visual noise. Whereas the second is much better. It's a simple design that keeps focus on the data. Okay, like here, Okay, so this one is simple. Like here, there's putting these grid lines. It's not necessary. That just creates visual noise. Okay, so you can make simple designs like this, and we can. And I've talked of comparison. It's easy to make for people to perceive things when you compare things. Like when comparing the older and the younger population, you can place older percentages values on top and the younger percentage values at the bottom. So it becomes easy for people to compare. Oh, this is older or this is younger. Right. Then legend simplification. That is, we all know what a legend is. Graphics should be placed very near the associated text. Don't just put labels to your graphs, to your visualization haphazardly. Because human eyesight is only a narrow range of focus. Put things that are associated together. Simplify your legends. Then you also need to simplify your data. You don't need to overload the display with too much text. It will be classified as noise, visual noise. Okay. Then I've an example here. Too much details. This will distract the viewer, but you can produce smart displays by breaking these displays, like breaking this one into its own maybe table, and breaking the second one and third one and fourth one, like that. Then we have emphasis. Now emphasis, we have talked about color, weight, etc. If we use of different colors on the same data distracts. Okay, this is color emphasis. Don't use different colors. Blue, red, green, pink, etc. But use the same color if you want to display the same data. Okay. Then, okay, we have talked about color emphasis, where we are. Color is one of the quickest elements to capture attention. Right? Color, we can talk of color in the sense of if you want to emphasize something. Normally, if people see red, they quickly look at red is intimidating at some point, at some instance. Okay, red for danger, but it also can be used for drawing attention. Okay, so the choice of color is also very important, and you also need to label your. Oh, it's now 9:05. Let's just finish this slide and go for a short break. Now, so we also have talked about Edward Tufte's principles. Okay, now let's look at Gestalt 6 principles of perception. So we are borrowing these principles from these authors or from this literature to help us come up with better visualizations. Now, so Gestalt talks of proximity, similarity, figure and ground, continuity, closure, and simplicity. So proximity, he says objects that are placed close to each other will often be perceived as one group. So you should bear that in mind when doing visualizations. Similarity, objects that look alike with similar components or attributes are more likely to be organized together. If you see that these things are similar in your visualization, it's good or best to group them together. Figure and ground, viewers will perceive an object and a surface even if shapes are grouped together. And continuity, object will be grouped as a whole if they are collinear or follow a direction. Okay, and closure, in perception, there is a tendency to complete unfinished objects. We tend to ignore gaps and complete contour lines. That is what how people perceive things. They tend to complete unfinished objects. So simplicity figures are seen as their simple element instead of complicated shapes. So don't use complicated shapes for visualization. And so these are the principles that Gestalt and Tafte talked about that will help us make better visualizations. All right, so I think we can take a break, maybe 5 minutes. How many minutes should we break? And then we can resume with our slides.
Minutes.
5 minutes. So it's 8:08. Let's meet at 9:15. Okay.
It's 9 o'clock in where you are, say. You've been saying.
Sorry? Oh, it's my okay, my computer. It's 8:11. Oh, so I'm thinking the from my way. All right. So let's meet at 11:15. Right. So 11:15. So I'll just let me just load the next slide.